Hey everyone, welcome to another session of CeerazzleDazzle Physics. In today's session, we're going to be talking about velocity time graphs. First of all, we need to compare displacement time graphs and velocity time graphs. So let's say a car takes 10 seconds to travel 50 meters. It travels at a uniform speed of 5 meters per second. Plot a displacement time graph and a velocity time graph, and let's compare them. So we know it takes 10 seconds to travel 50 meters, so I can draw that on my graph for displacement. So it looks like that for displacement time graph. Yeah, because after 10 seconds it's traveled 50 meters, that's my displacement time graph. But what about the velocity time graph? Well, to work out the velocity, we know that to work out the velocity, it's going to be displacement divided by time. Yes, velocity is equal to displacement over the time. Right, so it's moving at a uniform speed. So how would I draw that graph? Right, because the velocity is not changing, it would just be a horizontal line. So let's say, let's go for 1, 2, 3, 4, 5. As the velocity is not changing, it will just be a horizontal line for those 10 seconds. Okay, so now we have two graphs to describe the same movement. So look, they're different. Yes, one of them is displacement, and one of them is the velocity. So they are different graphs. Make sure you know the difference between a displacement time graph and a velocity time graph. Okay, scrolling down. Let's go. What does the gradient of a velocity time graph represent? So let's say you're given this graph and you're asked to work out what the gradient represents. So you know that the velocity, so we can see here between 1 and 4 seconds the velocity is changing. So we know that the velocity is changing. So what do we call it when the velocity is changing? We know it's going to be therefore accelerating. So therefore the object is accelerating. So the object itself is accelerating. So if I was to do this and work out, so let's say the gradient, to work out the gradient of the line, it is simply the change in y over the change in x. What is my y quantity? It's going to be, so the change in velocity divided by in the x-axis I've got the time, change in time. So change in velocity over the change in time, we should remember, is the acceleration. So that is the acceleration. Oops, can't spell it. Is the acceleration. So, if somebody gives you a velocity time graph, the gradient represents the acceleration. Yeah, easy stuff. So let's work it out for this one here. So, to work out the acceleration, I simply need the gradient of the graph equals the gradient. So, what's the change in y for that line? Let's pick 2 points there and there to start. So the change in y is going to be, so labeling it, that's my change in y. That's my change in x. Change in y is going to be 6 minus 0 divided by 4 minus 0. So therefore 6 over 4, it's going to be 1.5, and the units for acceleration are meters per second squared. Wonderful. So now we've done that. Yes, acceleration, change in y over change in x, and therefore it's the gradient of this graph. Easy stuff. Now, so we know the gradient of a velocity time graph represents the acceleration, but what about the area of a velocity time graph? So let's say we're given a velocity time graph and we're asked to work out the area. Yeah, what does the area represent? Well, to work out the area of this, I simply need time. So the area under that line, it is base times by the height. The base, what's on the x-axis, is the time. The height is the velocity. So what do you get when you multiply, so with velocity times by time? What is that equal to? Right, well we know that velocity is equal to displacement over time, therefore velocity times by time will be equal to the displacement. So yes, the area represents the displacement. So if you're given a velocity time graph and you're asked to work out the displacement, all you simply do is calculate the area under the line. So let's do it right now. So if someone says to you, let's work out the displacement. it is simply the area. So to work out the area under that line, it's this bit here. So therefore it's going to be 8 meters per second times by 7 seconds. Let's do that. So we've got 8 times by 7, we've got 56 meters. Wonderful stuff. So that's it. Give yourself a tick. Feel good. So 56 meters. Scrolling down, testing your understanding now. We're going to calculate the acceleration of the car from this velocity time graph and calculate the distance travelled for the journey. So right now we've got this graph here. So the first task is to work out the acceleration when it is accelerating. So which part is it accelerating? Well, this part is going to be the accelerating part. This part, it's not changing velocity. This one is going to be constant speed or constant velocity. So if I'm looking at the acceleration, all I really need to look at is this point here, between 1 and 4 seconds. So only between 1 and 4 seconds, I'm looking at the acceleration there and there. And we know this. To work out the acceleration, I simply need to work out the gradient of the line. So to work out the gradient, it is simply the change in y over the change in x. Pick 2 points on my line, over here and over there. So my change in y, so label it on there, there's my change in y, here's my change in x. Change in y is going to be 6, change in x is going to be 3. So the change in y is going to be 6 minus 0 divided by 3 minus 0. Therefore it's equal to 2 meters per second squared. Very nice. Now, what about the distance? How would I work out the distance travelled? Well, to work out the distance, I simply need to work out the entire area of this thing here. So the entire area. Let's go for... So to work out the area of it, I need to work out the area under the whole thing. So the area of all of this. For the entire journey, I need to work out the area of the whole thing here. Right, so from here, let's start. To work out the distance, I know it's going to be simply the area under the line. So I need to work out the area under the line. But you've got now the following shape. You've got a triangle, yeah? And you've got a square. So I'd work out the area of the triangle plus the area of the square. So simply it's the area of the triangle plus area of the square. Okay, so let's go. So this bit is the square. So this bit is the square. And this bit is my triangle. So I can work them out separately. So the first one, the area of the triangle is going to be half base times by height. And the area of the square is going to be simply base times by height. Okay, so half, what's the base of the triangle? 3. Half times by 3 times by the height of the triangle. Height of the triangle is 6. Plus, for the square, the base of the square is 7 minus 3. It's 4. Make sure we can see that, yes? The base of this bit over here, yeah, that's going to be 4. 7 minus 3. 4 times by the height, 6. So now we've got the whole formula here. So this is still the distance. This is still distance. So it's going to be half times 3 times by 6. So 6 times by 6 times by 3 times by 0.5. Bang, we've got 9. 9 meters. Plus the area of the square is going to be 4 times by 6. We've got 24. So the distance is equal to 9 meters plus 24 plus 9. It's going to be equal to 33 meters. And that's our answer. Okay, yeah, so if we're asked to work out the distance for this journey, you can split up the problem into simple shapes, triangle, maybe a square, work out the area of both of them separately and add them together to work out the total distance. And obviously to work out the acceleration, I simply use the gradient of the line. Okay, now scrolling down. Summary. The gradient of a velocity time graph represents the acceleration, and the area of a velocity time graph represents the distance. And that's it for today's session. I shall see you next time for more CeerazzleDazzle Physics. Goodbye.